and I speak as an Indonesian technology company to define where are the next investment opportunities today. I would like to brief the contents that we will deliver today. The first one is the challenge and opportunities to process the laterite ore that consists of saprolite and limonite, where each of those compound and the content has different characteristics and challenge itself. And the second one is how about the raw material outlook, including nickel and cobalt, and this to support the development of EV battery industry in Indonesia, as supported by the government in the heliodization of EV battery. And the third one, the future technology in nickel smelters. This is the main focus of our discussion today. How is the comparison about the pyrometallurgy and hydrometallurgical process? And the last one is about the business process. How is the prospect and the potential of the nickel smelters in Indonesia? So I'd like to remind about this, as this is the fact as a starting point. Known as the biggest nickel resources in the world, Indonesia is gifted with abundant laterite ore resources that have made the country become the world leader in nickel. And this is, I think, we can become a future contender for being a leading force in the EV battery industries. The opportunity here in Indonesia is we have a vast amount of nickel ore close to the surface. The ore profile has two parts that contains of limonite and saprolite. Each of those compound has different result in the end product. For the limonite would be resulted the class 1 nickel for battery grade nickel. As we can see, the main product is nickel briquette, nickel cathode, where the intermediary product is the MHP, NHP, and MSP. At the moment, Indonesia mostly mine the saprolite that resulted in the class 2 nickel, resulted the product of nickel pig iron, ferronickel, and the nickel matte. As today, Indonesia only mines saprolite, at least until Legend Persada start to ramp up in the mid of this year. As Indonesia NPI's production has grown, there's now a huge amount of saprolite that is mined each year. So this is what we have to concern, because to produce the EV battery industry will be required the nickel class 1, and the suitable material comes from the limonite. At the moment, this limonite ore hasn't optimized since as we noted that there are several companies that try to construct the HPAL that would be constructed the hydrometallurgical technology process, and estimated it would be around the production around 250,000 tons as nickel for the next 3 years in the 2025. We can simply saying that the limonite ore that will need to support the downstream of EV battery industries, that very fast limonite resources are not fully utilized until this moment. And the interesting study released by Roskill, what we would like to deliver here is there is where the projection triggered by the growing demand of electric vehicle batteries that expected will use nickel class 1 as their raw main material. If we look into the chart where the demand and supply of nickel class 1 forecasted deficit around 400,000 ton in 2030 and continue to increase up to 1 million ton in the 2040. But here I want to say that the problem is not in the nickel resources itself, but the bottleneck is on the processing technology instead. As the only one proven hydrometallurgical technology at the moment called HPAL, with their estimated production all over the world, will not be able to supply the global market demand. And we think this is something that should be anticipated by all of nickel industry stakeholders, particularly in Indonesia, means if we cannot find the solution, most likely the big player like Tesla, with all of their resources, will easily find a way out to use another material beside nickel to secure their value chain in industry process. So our conclusion here is nickel class 1 plays an important role to fill the gap on lithium ion battery demand, as we noted that EV battery demand will expect to rapidly growing for many years to come. And if we discuss about what is the technology providers that can be able to result the nickel class 1 and product, if we talk about the technology, I believe there are many technology provider exist in nickel extraction process, but uh, I would like to discuss the three proven technology that exists in Indonesia. Another one is being developed by the Indonesian technology company. The first one, saying RKF, rotary kiln electric furnace, that would be able to convert their main product of nickel pig iron to nickel sulfate. The RKF is one of the most proven high pyrometallurgical technology here. And the HPAL, though is not being used in Indonesia until President Legend yesterday start to ramping up. This is the one of the proven hydrometallurgical technology that exists. And the last one, I think this is the technology that provided by the Indonesian technology company called STAL, step temperature acid leach. So the first one, if we talk about the pyrometallurgical technology, RKF is one of the proven hydrometallurgical process. I mean pyrometallurgical technology, and become the most common use all over the world. Indonesia has been enjoying this technology since many years ago, with low capex and gas costs, and then the fastest ramp up, but using highest temperature, and resulted slag as residue. This is the capex is low and gas costs in compared to HPAL. So RKF technology basically only suitable for nickel class 2 market. They will be able to have further converting process from nickel pig iron to nickel sulfate. As we can see here, with additional cash around 4,000 US dollar per ton. I think one of the case is the SLN smelter in the New Caledonia, but at the moment now being stopped due to cost issue. Nonetheless, the Singsan started to develop on how to doing those conversion process. Another downside is high carbon footprint and energy consumption to use this converting technology. So the second one, the proven hydrometallurgical technology called HPAL, that produce mixed hydroxide precipitate. They're feeding only by limonite ore, and use the acid manageable acid usage is around 400 kilogram per ton, and use the temperature around 250 degrees Celsius, but using the high pressure as their main machineries is the autoclave. Started being ramped up in the average of 6 years, with the a bit high capex and gas costs around 50,000 ton as nickel, and gas costs around 10,000, and resulted slurry as the residue. HPAL also comes with several advantages and downside. The advantages, as the proven hydrometallurgical technology, they would be able to provide the high nickel and cobalt extraction at the fastest extraction time, and also manageable acid consumption. And also with several downside, the HPAL process is highly sensitive with the limonite ore characters and change. So that means we can have a different characteristic every day for the limonite ore due to the sensitivity on the machineries. Since this is the complex technology and required the complex maintenance, resulted high capex and opex, and also high risk failure for around since 1960s. There are only below 20 HPAL smelters in the world, and only many of them have been success in the ramp up production. So the HPAL also need long ramp up time, and the most important is how we monitoring this technology in terms of the waste management process. Looking in the side of the history, I mean the projection of HPAL capacity project in Indonesia, there are two another company aside of Almahera Persada Legend that would be going ramp up totally around 150,000 tons as nickel for the next 3 years in 2005. So looking toward this technology, the other one technology called STAL technology, step temperature acid leach, that focus in developing hydrometallurgical technology to extract metals and minerals include of nickel with environmentally friendly process. And this is the Indonesian technology that we can expect be able to support the downstream process of EV battery industry in the country. So at a glance, who is the behind the STAL technology? There's the company called Hydrotech Metal Indonesia or HMI. This is Indonesian company that focus on the research and development of energy metal. And the technology has been registered the patent aside of Indonesia in several countries. And the company itself would be planned to stock listed in the Canadian Stock Exchange within this month. And this is the main focus of the company to fill the value chain of the industries, as the focus of the company is to develop the technology. Their position in the middle of the value chain process that able to produce the MHP or mixed hydroxide precipitate. And furthermore, the focus now is how to develop the battery precursor and or NCM precursor directly from the MHP process. And another thing is how we manage the residue and how we convert this residue into byproduct that would be useful for another industries. And this is something that we would like to deliver our position in the nickel value chain industries. And today we will try to support the value chain process. And a glance about the STAL technology process itself. The technology input process resources from the wide range of laterite ore, from the limonite down to saprolite, with capacity around 600 dry metric ton ore per day. And also same like HPAL using sulfuric acid as chemical to react with the ore, and in the certain temperature process with the high temperature where the ferrous and aluminum, which is the most content in the limonite ore, will decompose and release SO3 gas. And this SO3 gas will be react with the ore compound inside the process, and we're breaking down the silica, and this is the recovery process would be happen. The SO3 gas would be captured by the scrubber, and aside of our main product MHP, it would result in another byproduct ferrous aluminum as a residue that can be converted into byproduct, as well as MnO2 and magnesium sulfate that would be useful for the farming industries as fertilizer. Speaking about the nickel processing technology, of course, we cannot afford how we manage our waste management. If we taking back for the HPAL process, there are three options that can be used as our waste management. The first one is conventional tailing dam. This is the very common waste management system, but there come with several downside, like the prone to the earthquake, and it can be resulted the risk, the impact for the environmental. And the second one, the deep sea tailing disposal. Even though our government still discussing about this is something that needs to be concerned on how uh, the tailing would be come into the sea, and it's not good for the public perception, I think. And the last one as well being mentioned, by Fabio in the previous presentation is dry stack tailing. But again, the good quality of product comes with the high price. I think that's something that we have to consider by the respective industry players. And the interesting one is, as we've been observed with the expert calculation that calculated the carbon emission comparison between the three technologies. Of course, rotary-killed electric furnace have the highest carbon emission due to the machineries they use. And for the hydrometallurgical, we can see that similar numbers of HPAL and stall technology. From this calculation, stall technology is the lowest carbon emission compared to another process with 17 up to the 22 kilogram CO2 per kilogram nickel. And if we talk about emission and how about the waste management, as well being said that the stall, the biggest component of the electric ore consists of ferrous and aluminum, which are around more than 40%. And this is something that we have to manage. But the process installed that would be able to process the ferrous and aluminum into byproduct as iron ore that can be utilized for the steel industries. And the slag of the iron ore itself with resulted bricks, the final bricks that can be utilized for another industries. So as our conclusion here is the steel technology has the lowest carbon emission among the technology and also process waste into valuable byproduct that make steel environmentally friendly. And if we talking about the nickel industry in Indonesia, we have to aware that Indonesia is unique, and their characteristic is different than other nickel mining sources in another country, because most of the mining concession is around 300 is consists of the small and medium mining concession that that hold around below than 5,000 hectares for each. So it's around 90% of mining concession are having below 5,000 hectares each. And with those conditions, the stall technology initiated to build the e-scalability with a modular system designed for the small and medium nickel mine in Indonesia. With the first module layout with around 1,800 tons nickel per annum, and it would be scalable if the nickel industry player wants to scaling up the module. So the beneficial with using this modular system is it would be fasten the ramp up time with the total around 21 months, and similar like RKF plant. And this is the style technology, how we increasing and optimizing Indonesia nickel resources. The ease in scalability moreover, potentially add the value of small medium mine resources that mostly scattered in Indonesia. As the reserve definition are the certain mineral deposit that the quality and quantity are known as economically, then the calculation are made. Means that almost mine here is not really become a reserve until all of those variable is defined. Now its stall technology exists, hope that it would be able to help the miners to define their amount of resources. Around of 90% consists of small medium mining concession and calculated by the expert, the rest 10% only can be served the HPAL plant that required around 4 million wet metric ton per year, around 100 million per 25 years. That's happened with those 30 mining concession. But with how about the small and medium mining for the rest of 90%, with one stall module requires or supply from a mining concession reserve as low as 12 million wet metric ton low grade ore, with the estimated for around 25 years of operation that I think it would be covering the minimum area of the 260 hectares. So that what I would like to say is this scalable system of stall technology is suitable for small to medium scale nickel mining in Indonesia. This figure explains the comparison between the stall and other incumbent technology HPAL. Where the source we got it from I believe it's from Norilsk, from the Global Mining Research. First, in the capital intensity or capex, stall is 60% lower due to simpler machineries and equipment they use. And on the cash cost is 23% lower with the lower maintenance costs and the sulfuric acid consumption. So with this condition, we can conclude that the stall potentially positioned below 25th percentile in the world of the nickel industries. Surely this is the good thing for the company and moreover to add more value to the nation. This is the conclusion about the stall technology with several competitive advantage they have. What makes them different than HPAL is they operate in the atmospheric pressure, making the equipments and components easier to use, and the stall waste is easier to be managed, resulted more jarosite, less acid, and potentially processed further into byproduct. And the modular system, this is also the important as the scalability. One of the important thing is faster to build and achieve full nameplate capacity. And the most important thing as well is to ensure the utilization of limonite that mostly consists of small, medium nickel mining. And then the last one, the lower capex, the next pal due to simpler machineries and equipment. And as our summary today to answer the brief content that previously being mentioned is the opportunities and challenge for saprolite and limonite development is for saprolite, Indonesia continue to have the huge amount of saprolite development and potential in the world, but it is increasingly competitive as saprolite grades drop and as the production rates increase, there will be increased cost pressure on the saprolite production. And then in the meantime, the main opportunity is the fast limonite resources in Indonesia. Main challenge is, of course, the waste management and the limonite benchmark price. We have to note that it's still being calculated by the government, which is potentially quite high. And the outlook for nickel and cobalt, as the nickel price has been high through to 2021 because of the high demand from stainless. But in the future, there will be pressure on the nickel pig iron market as stainless demand growth may not be as high. However, for class 1 nickel, there is continued optimism for sustained high nickel and cobalt price due to the exponential demand growth from the EV sector. And the last one, the scalable is important. What I would like to emphasize is this is looking back into the mine characteristic in Indonesia. The three factors that need to be considered by the nickel industries. The first one is cost. Of course, this is would become the competitive advantages that would have to deliver by the nickel industries, and the scalability. Again, the scalability is important. Looking toward how is the nickel mine characteristic in Indonesia, and the last one. This is the word that being told over and over is about the ESG, and as we noted that this is the one that every respective stakeholders would like to compliance. So I think that is our presentation today, and back to you, Ben.
Great.
Thank you.
Thank you, Romy. We have about 4 minutes for Q&A. Okay, so Jeff Tucker's asking about future problem for Indonesian coal products for batteries is likely to be coal-fired electrical power stations having a high carbon footprint. Is the government of Indonesia prioritizing geothermal or tidal? You're gonna get tidal, sorry. Tidal powered station feasibility studies to provide renewable baseload power in these regions?
Yeah. I think I'd like to answer from the Jeffrey Tucker. Thank you for the question. We noted that the energy power is being one of the concern in Indonesia, and this is something that we have been discussed with the several providers. Aside of geothermal and tidal power station, we see the potential to use the LNG as our main energy power for the heat balance aside of electricity. And yes, this would require collaboration between several parties, between we are as industry players, and then the energy providers and also the government. I think the problem is what the energy we have to use, but what will the respective stakeholders would like to support these industries using their knowledge and using their capabilities to support the industry.
Okay.
Hope those can be answered.
I think that answers Pa Untung's question as well. It was about renewables. And then Ian Wolf, you mentioned limonite feed ore for the STAL project, the STAL process is less than 1.5% nickel. What's the lower level cutoff grade to keep STAL process as an economic business?
Yeah, I think it's that good question. As we mentioned, STAL technology process input can be absorbed the wide range of lateritic ore from limonite down to saprolite. Now, in our industrial pilot plant, first we use the saprolite that contains the high grade of nickel, but we've been validated by the government and the research institution through the ESDM, and we validated the STAL technology process from low grade of limonite down to the saprolite. The low grade limonite, we choose the 1% of nickel content, and it's resulted still visible on the projection. So I hope this answer the question that yes, the STAL technology would be able to process the limonite ore, because those limonite ore contain less magnesium, so it would use less acid in the process.
Okay, great. And that actually brings us exactly to time. Well, thanks, Pa Romy, for your presentation, and yeah, it's nice to see Indonesian homegrown technology taking a foothold here.
Yeah. Thank you, Ben.
Most welcome.